Reciprocal means if you have the reciprocal of A, the reciprocal of A is 1 over A. So reciprocal function comes from the reciprocal of the trig functions that we know. So CSC stands for the cosecant. So the cosecant of theta is actually the reciprocal sine function. That's different than the inverse sine function. The secant of theta is the reciprocal of the cosine of theta. And the cotangent of theta is the reciprocal of the tangent of theta. So the secant or cosecant goes with sine, and the secant goes with cosine, and the cotangent goes with tangent. So first example, if the tangent of theta is 3/4, so I'll put theta right here. If the tangent is 3/4, draw a right triangle and determine each other ratio. So remember, tangent is opposite over adjacent. So this would be 3 and this would be 4. So I could do 3 squared plus 4 squared to get the hypotenuse, which is 5. So now I have all 3 sides of the right triangle. I can do these ratios. So cotangent is 1 over the tangent of that angle. So if the tangent is 3/4, so this is going to be 1 over 3/4. So the cotangent is going to be 4/3. So basically, instead of writing out 1 over this, I'm just going to flip them around. Okay, I'm just going to flip 3/4 around because I'm going to end up multiplying by 4/3. Okay, second one, the cosecant of theta is 1 over the cosine of theta. So cosine of theta off to the side here is adjacent over hypotenuse. So that means that the secant must be hypotenuse over adjacent. So this is going to be 5 over 4 because 4 is adjacent. Okay, the sine of theta is opposite over hypotenuse, so it's going to be 3/5. So now I can do the cosecant of theta is just the sine of theta, the reciprocal of that. So that's going to be 5/3. And the cosine of theta is 4/5. Okay, using the reciprocal functions, you can find the exact value of each. So the secant of 3/4, 3 pi over 4, 3 pi over 4 is going to be in this quadrant. It's going to create a 45-degree reference triangle because 3 pi over 4 is 135 degrees. So I can put in root 2 over 2, and then the y would be positive root 2 over 2. So secant is 1 over the cosine of 3 pi over 4. So cosine is the x. So this is going to be 2 over root 2, the negative. So last what you want to do, because I just flipped this over. So the second thing that you want to do, or last thing you want to do, is rationalize it. So I'm going to multiply the top and the bottom by root 2. And that is going to give me negative 2 root 2 over 2. And so that's going to simplify to negative root 2 is my final answer. Example 2, find the exact value of cosecant of 30. So this is the same thing as 1 over the sine of 30. So I'm going to do the sine of 30. So the sine of 30 is going to be 1/2. So doing 1 divided by 1/2 is the same thing as just writing 2. So the cosecant of 30 is 2. Okay, cotangent of 2 pi. So this is the same thing as doing 1 over the tangent of 2 pi. So let's do the tangent of 2 pi. So remember, tangent is just y divided by x. So this is 2 pi. The coordinate's going to be 1, 0. So y divided by x is 0. So this is going to be 1 divided by 0. So So cotangent is going to be, when 0 is underneath, it's going to be undefined. Because whenever you divide by 0, it's undefined. Okay, next one, secant of negative 120. So that is the same thing as doing 1 over the cosine of negative 120 degrees. So cosine of negative 120 is your reference angle is going to be a 60-degree angle, and the cosine is going to be negative 1/2. So this is going to be 1 over negative 1/2, which is negative 2. So the secant of negative 120 degrees is negative 2. Cosecant of 5 pi over 4. So 5 pi over 4 is 225 degrees. Cosecant is 1 over the sine. So the sine, if this reference angle is 45 degrees, the sine is negative root 2 over 2. So the reciprocal of that is going to be negative 2 over root 2. So again, you want to rationalize it. So you're going to have negative root 2 over 2 over 2. So the answer is negative root 2. And then the last one in this set, the cotangent of negative 210 is going to be 1 over the tangent of negative 210. So I'm going to do the tangent of negative 210. So tangent negative 210 is going to go 30 degrees up. So this is 30. That's going to be my reference angle. And then this is going to be positive 1/2. And this is going to be negative root 3 over 2. So instead of doing tangent is y divided by x, cotangent is going to be x divided by y. So I'm going to write this as negative root 3 over 2 divided by 1/2. Now, this is a complex fraction, so I can multiply the top and the bottom by 2 over 1, and the 2's will cancel out. So I'm going to get negative root 3 as my answer. Okay, now also you can solve. Use your graphing calculator to solve for theta on the interval from 0 to 2 pi. Round to the nearest hundredth if necessary. So your calculator doesn't have a way to directly put in a reciprocal function. So you need to write down what you're putting in your y1 and y2. So it's important to notice that the interval is from 0 to 2 pi. So this means you need to set your x min at 0 and your x max to 2 pi in your window. Also, you need to make sure right here that you're in radian mode. So for the first one, I'm going to put y1 is 7, and then y2 I'm going to write as 1 over the tangent of 2 theta. Now, depending on your calculator, I would just put this whole thing in my denominator. I'd put the whole denominator in parentheses. So I'm going to pause it and then write the solutions right here. So the solutions are going to be where you want to intersect, where they intersect. So I'm just going to draw a sketch of this graph. So on my graphing calculator, it's basically just in this first quadrant right here. So this is the line y equals 7, and then cotangent are looking like this. Oh, I didn't draw this well enough, but there's 4 times where it's intersecting. So you're going to want to calculate those 4 intersections. So I'm going to keep going over here, and y1 is 2, and then y2, I'm going to want to write this. Remember, this, you don't actually write theta in here, you can write x on your calculator. So y2 is going to be 3 minus 1 over the sine, because that's a reciprocal function, of x plus pi. So be careful when you're doing this in your calculator. I would put this in parentheses. And what you're going to do is see where they intersect. That's going to be your solution. So I'll actually do this one out and then write my answers down so you can try it too in your graphing calculator. So when I'm graphing this on that interval, it looks still kind of in the first quadrant, and then I have y equals 2 going across, and then I have this cosecant function looks like this. So right now when I'm looking at it, it looks like it might cross once. So what I'm going to do is I zoomed in my window a little bit, and I'm going to calculate it and see if it crosses twice. So the only intersection on this function was about at 4.71. So it crosses one time. So the solution is 4.71.